Great. Well, so I'm Javier de la Torre. I'm the founder of CARTO, and it really is my pleasure to have you all today for the Spatial Data Science Conference. Well, there's two things that I really like about this conference. The first one is the fact that it's in New York, which to me is probably one of the most iconic kind of location to make maps. I think every map that is made in New York just looks better. The geography of the city is just amazing. I like in particularly this one. I don't know if you know it from the Berg Design Studio, this horizontal-less map that shows how Manhattan looks from here, from Colombia. But I think that is really great. So New York is always a very exciting and inspiring city for this conference. But also Columbia University, I think, is one of the research institutions that is doing a lot around geography with the Earth Institute and the Spatial Research Center. So there's a lot of geography happening geography research happening here at Columbia. So there's a bunch of you that work here, and I think it's a great mix for this conference. So I'd also like to thank all the sponsors of the conference. If you look at the sponsors that we got now at Spatial Data Science Conference, it says a lot around our industry. I mean, we got the major cloud vendors and some of the most important data clouds that are right now in the industry, and so also some of the biggest data providers of our industry. I think that combination says a lot around the growth of spatial data science as a field, and the importance that it is getting with the growth of the conference. It shows us a lot. So I think it's a great opportunity to get to know them. So there's booths that you can go and check out later. They will be all around. I highly recommend you to go and talk to them, learn around the latest technologies that they have. The data providers, they have amazing data sets. I think there's a great mix to learn what is happening in the industry. So for today, there's three things I was primarily thinking about talking that I think are fundamentally shaping the area of spatial data science. So the first one, it is around the impact of the data clouds. Right? I mean, the latest on technology and analytics in the cloud is really shaping analytics, and it's going to have, and is having already, a big impact in geo, as you will see. I would like also then to talk a little bit about, particularly around spatial indexes, about how techniques to do a spatial data science that I think are right now, we see a lot of organizations utilizing that I think have a big impact in anybody that is considering doing analysis. And the last part, I want to talk a little bit about something very exciting to us, with some announcement around how we can democratize further the spatial analysis, right? I think there's here a big crowd of big experts on spatial data science. I think we want to have many more people in here, and I think, as a community, how to reduce the barrier of entry is going to be very, very important. So let's get started. So in the first one, let me talk a little bit about the data cloud. So data cloud is really kind of enabling us, from an analytics perspective, some very big ways, big difference in the way that we do analysis. So there's, from my point of view, 3+1 kind of big changes that are happening. So the first thing we're talking is obviously around the scalability of the data cloud, right? I mean, the capabilities that you have in terms of analyzing much more data in a much more powerful way because of the cloud is very, very important. But it's also very important that it's very cost effective. The computing and storage separation is really enabling now to pay only for what you use, but also kind of in a very effective manner. We'll also think, and we'll talk more about the fact that a lot of this analysis is now being made available through SQL, which from me is a very important point because it enables many more users and much more integrations with other products of analysis and kind of breaks a lot of the silos. So those three things right now I think are fundamental kind of drive of change on the analytics kind of industry. But if you look at the fourth thing, the rise of what we call the cloud data shares, the concept of sharing data between different users or different providers and all kind of live in a single database, I think it's mind-blowing. And that's actually what I want to be focusing today on this part. So the idea of this paradigm of these cloud data shares is that you have all these now providers, or you have companies and other organizations that you need to collaborate to get to use their data. And by being all in the data cloud, it almost feels like we're all living in a single database. That's the best kind of like analogy that I can think of. Imagine if all the data in the world was just a join away on your SQL. This is actually really what is happening now with the data cloud. With data search, you can get like a data set, inject it, and make it available in your data warehouse, and be able to query it live with your own data without having to do any ETL, getting updated in real time. That is, to me, is the holy grail in a way of like data integration. It is an incredibly exciting moment for the industry and enabling this type of analysis or this type of data integrations. Now, but if we think about how we bring this to the geo world, right? Is this available for us for spatial data science? And the first answers to the question is yes. Most of these data clouds and products already support geo, which is the great news, and that's why a lot of them are also here today. So in most of these products, you can find support for geography, geometry, different kind of like spatial indexes, and that is fantastic. But there's still actually not interoperable between them. If you, let's say, import or export a data set from BigQuery and you try to use it on Snowflake and then you move it to Databricks, the geo column, if you want to say, like the geospatial information, will be transmitted, but it will not be understood. There's not interoperability yet between these systems. And this is a problem because that breaks this whole vision of integration of your data with third parties and so on, right? So for that, over the last year, we've been working on trying to solve that problem on the concept of a project we're calling GeoParquet. So it is our try to provide interoperability inside the ecosystem on the data cloud. Yeah, so it is a community-driven initiative, driven first of all by many private companies who are investing on this, and also in partnership with the Open Geospatial Consortium as a standardization body. So to me, it's important because it represents an effort as an industry to call out drive and some standardization and something that is very key, but also being done in a very community-driven way. So it's actually all the discussion and all the format and all the standards is actually kind of like getting described openly in GitHub. So check it out. Now, what this will enable. So the vision of GeoParquet is that once we kind of like pull it off, I mean, not only you will be able potentially to kind of like export from one product, import in others, and respect the geospatial columns, it's also that you, as providers, and there's a lot of you here, will be able to publish in a single format, and that data sets will be able to leverage in many, many different systems, right? And I think, like right now, we're in an incredible opportunity to achieve this. Most of those products have not yet defined how they support geospatial and Parquet. If we do that, I mean, we're coming to a new area of interoperability on the geospatial world, which to me is really, really exciting. Now, Parquet has some very, very core advantages. Parquet as a format beyond geo. I mean, it's a format that has been with us for, I think, now almost like 8-9 years. So it's a pretty stable format. It's very, very popular to work with very big data sets. It's very popular because, like it supports for storing, like all sorts of type of data. It works really great in the cloud, and all the major products support it. If we manage to make it, support also geo, we have actually, I think, and I'm going to regret this, we have the potential of actually replacing the save file. I'm saying, I might regret it because I know that at the end of the day, no matter what we do, you will keep exporting to save files. So we know it's going to happen. But I mean, I think it's a great opportunity that we have in here to modernize the way that we handle geospatial data. I think Parquet will be that opportunity. Now, where we are on this, we have already a very stable version of GeoParquet. But one very important component, which is GDAL, already supports GeoParquet. Also does CARTO for import and very soon for exports. So there's some very fundamental blocks, fundamental products that are already supporting with more to come. So actually one of the things that we are announcing is very soon is the publishing a lot of CARTO data observatory data sets on Amazon Data Exchange. which is actually a data exchange that enables for one of these data sets that we were describing. So I think it's going very well, very much in the right direction, and we're very excited about it. So that was the first part. The second part I want to tell you about is about how we do data science, spatial data science, right? I want to talk about something that I see in the organizations a lot these days, which is, okay, what geographic support system we use. Most people don't make the question like that, but but they're like trying to figure out what is the data models, how do they model the data on their databases to enable spatial analysis. And there's been, over the last years, an incredible revolution around that with the usage of spatial indexes. And for that, I actually want to start by sharing, we did an application with Snowflake analyzing looking at the analysis on the food delivery industry, looking at what are the KPIs that are interesting to that industry, how can it be calculated, and how we can facilitate on that. So if you look at that industry, we all use it, we've all ordered food online. There's three main things that you are matching. You have to match where the customers are, where the restaurants that have the food are, and how you're going to do the routes to match one to the other, right? So most of those companies, they have in some different forms on their databases this type of data: restaurants, customers, routes, GPS points as they're delivering the data. Now, how do you actually transform that into KPIs that are useful for your business? And in this business, one of the most important KPIs is the delivery time. I mean, the sooner that you get the food, the better the service that you're providing, or even more. The more accurate ETA, estimated time of arrival, that you provide to the customer, the better. No one likes their food to tell them that it's going to take 30 minutes and then it takes 45. So that's something that they care a lot. But how do you calculate this type of ETAs? It's many, many different ways. And actually, we showcase the usage of spatial indexes, and in particular, in this case, H3, as a great way to model your data in order to create effectively this type of indexes. So essentially what you have is these multiple data sources in different geographic support systems. You have them in boundaries, zip codes, in different formats, and you transform it into a common system, in this case, a grid, a global, a continuous grid, and you calculate your KPIs from it. And that has enabled some of these organizations to be so much more effective on calculating these KPIs in real time and be more precise on the usage of them. So that's actually pretty exciting. What are those spatial indexes? I'm sure that how many of you are already using H3, S2? There's a lot of you already. So it's probably half of the audience right now, which is great. I mean, and if we asked this 3 years ago, there will be only a few. So that's actually something that is very clearly, having a very profound impact on our industry. So there's different type of indexes. Think of, these indexes as grids, a way to partition the world. But there's a type of indexes, which we call global hierarchical indexes, that allows you to split the world in a congruent way so that you can go, let's say you can zoom in and you can zoom out. You can transverse it, in a pyramid. So these type of indexes provides a set of, capabilities, as you will see, that really make it very efficient to work with very large amounts of data and to use a lot of really nice tools. There's three right now that I think are the most popular that we see a lot. H3 is these hexagons. The S2 is the one from Google. Well, one was coming from Uber. The S2 was coming from Google. Uber, Google, and quad bean is something that it's called like a quad keys that we did CARTO, but essentially think of it like a word Mercator tiles type of splitting of the world. Now, why are these things so good? There's many reasons, but one of them is that they enable heavily parallelization of data because of you essentially making the analytics discrete from just moving from geometries into a discrete set of cells or a grid that is much more effective for the analysis. So think of it that at the end, when you do this, what you transform is a geospatial problem into a regular join problem. And this type of SQL joins is where these data warehouses are amazing at doing. They are used to work with billions, trillions of records and be able to do these operations. So if we can transform our spatial analytics to something like this, we get all the benefits of the incredible massive parallelization that these data clouds and data warehouses are right now putting in the market. So I think for me, that's enough as a reason to use them. And for that, actually, at CARTO, we've open source libraries to use H3, S2, and quad beans in most of the major data warehouses. So we'll see, like Databricks has just announced native support to them. But if you need them on Redshift, on BigQuery, or in Snowflake, there is a data package that you can use from CARTO to leverage them as part of the analytics toolbox. And again, it's not only the fast analysis that is interesting. It's also comes with advantages around data integration. If you're using third-party data from one of your data providers, and they give you the data already in one of these spatial indexes, combining it with your data is so much easier, right? So it has a lot of advantages around data integration. But it also has great advantages towards the convergence of vector and raster. So we are now storing raster data in data warehouses like BigQuery, Snowflake, and Redshift by using these spatial indexes. So to me, that's at the end, the ultimate goal, that we can treat all the spatial data in the same way and effectively query between them and do analysis between them. I think that's incredibly exciting. Let's see. Actually, one of the things that we just released at CARTO that I'm also very excited about is the support of spatial index tiles. So if you have very, very large data sets that you want to use with the spatial indexes like this, we've already come up with a way to dynamically aggregate them for visualization. And that is very effective when you're working particularly on things like telemetry from GPS. If you're collecting billions of GPS points and you need to visualize it in an effective way, we've been doing a lot of research like that, and it's working amazingly. So that's very exciting. Databricks also, we will have a talk later, but Databricks is the first one that has introduced H3 support natively into the product. That is, I think, is mind-blowing. It's really good. But I can only imagine everybody, all the other data warehouses, adding them to natively. You can use the bindings that we provide at CARTO, but in the case of Databricks, there's already support for H3 natively, and even accelerated with some of their acceleration engine called Photon. So it's just going to get faster and faster. So that's why I think it's a very bright future towards that. Right, so that was the two first things I wanted to talk about. The third one I wanted to bring was around who can use, who can do a spatial analysis. And I think, again, looking back at the analytical and the analysis industry, low code and enabling more generalistic data analysts to do analysis is a very, very big trend. There's not enough data scientists to solve all the analytical problems that organizations need these days. So the low code or no code approaches towards simplifying how you do analysis is being very, very revolutionary. And the same we think needs to happen here in Geo. Now, SQL has already done a big part of that. So SQL, I would say, is a language that in a way makes possible a much larger audience to start doing analysis. And the beauty of this, we were talking about it in 2021, is that SQL is becoming the lingua franca of analytics. If you think about all the steps that you do normally in analysis, on ingestions, preparation, transformations, there's already some company or some products that are already providing those capabilities to SQL. So SQL is becoming that place that you can move, your analysis from one product to another and through the entire pipe process of analytics. So SQL is becoming really ubiquitous, and I think it's for a very good reason. But SQL at the same time can be misinterpreted. And many people think about SQL like that. Let's do a select and a word filter. That's super easy, super nice. Everybody knows how to use SQL. But when you go really into analysis, SQL starts looking much more complicated than that. And very quickly you end up with very, very large, statements that are very hard to debug, are very hard to understand, and then become very inaccessible to a large part of users. In fact, actually, this is an analysis that I did myself. And you very quickly end up with very, very, very big scripts of SQL for doing some of the spatial analysis we need to do, right? So there's, I think, a problem in there, right? And for that, actually, we did an analysis on a report for the state of spatial SQL. And I would like to invite my colleague, Matt Forrest, on stage to talk about it. So welcome, Matt.
All right, good morning, everybody. And can you hear me? Thank you for being here. So I'm a big fan of spatial SQL, and I think there's so much that it can change and boost analysis, be very, very powerful. I have been using it for a long time at my time at CARTO, and I've learned a lot, and I've been fortunate to learn from a lot of great people to help me really become fluent in SQL and do quite a bit of things that I couldn't traditionally do. And we can kind of see here that if you take a look at the report, spatial SQL is used in many different roles in geospatial, from a data science perspective, an analyst perspective, developers, data engineering, and more. But many are still learning this later in their careers. If you think of a traditional GIS career path or geospatial career path, only 10% of people are learning that in a traditional education setting. Most people are picking up SQL on the job through courses or different online guides. And that's a pretty common trend. That's 90% of people are learning SQL that way. And I think another interesting statistic is that it's still used infrequently in our industry. So 74% of people are using it weekly or less. Now, for something that powerful, those are some statistics that stand out and I think are important to call out. So what we decided and what we've been working on at CARTO is that we need an interface that helps more people use and take advantage of the performance of spatial SQL. And what we can see here is that across our industry, from the GIS side into people that might use geo on a more infrequent basis, in exposing geospatial to them, helping them use it more frequently. And like Javier said, spatial SQL is our lingua franca across analytics. The more we can do that and the more we can enable more people to collaborate with us, work and share that data together. So what we're very excited today to announce is CARTO Workflows. This is a tool that allows you to use SQL in an interface, helps you build and collaborate and make SQL accessible to many different use cases and many different roles. So for that, I'm going to hop into our demo here. So this is the CARTO workspace. If you notice, there's a new section here called Workflows. Now I'm going to open this up and create a new workflow here. So the analysis we're going to perform today is, imagine a scenario where we have a list of our customers, and we want to figure out if they are near a wildfire and share that with people in our organization. So the first step is I'm going to load our customer data. Now this data is not geocoded, so I'm going to go here and pull our geocoding node. And I also want to find people that are near the fires, so I'm going to add a buffer around that. So all I have to do is connect these different nodes. Oops. And provide the input. So these data is in the United States. And I'm going to give it a buffer of 5 kilometers. The other thing I'm going to do is I'm actually going to import some data. So we have here the massive active fire data, excuse me. I'm going to copy that link, and we'll import that new data. You can also see I can import that on a trigger to see if that's only new data that's existing. If I need to overwrite that, I can set that up that way. The other data I want to bring in is US states. So I'm really, in this case, only interested in fires in California. So I have my US state boundaries here, and anyone that writes SQL will know if we want to filter, we can just bring in a simple where clause. So I'm going to go ahead and connect that, use our name column, is equal to California. And then I just want to perform a simple spatial intersection. So we use our st-intersects. These should look familiar if you're using SQL on a regular basis. And now I have my 2 data sets that are ready to go and set up here. Oops. There we go. So now we're ready. I'm going to go ahead and hit run. What's great about workflows is it's going to compile this in a logical order, and it's generating the SQL under the hood, which is really powerful. So everything that's happening here is pushing down to the location your data's in. If that's a data warehouse, a database, everything there. We can see everything's running, and it's pulling, as you see, step by step here. When that hits green, that means we successfully run it. And once that's all run, we can actually check each step to validate that it's there, it looks good, it looks clean, and see that in a tabular form and in map data. So our intersection should be finishing up right now. And once that loads, we can take a look at all the data that we ran. Great, so everything ran. I'm gonna pop in and take a look at our geocoded data. You can see the data here and it on a map, all our points in California, and with our buffers tied to it as well. Down here, I can see our imported data from the fires. And that's gonna be a global data set. And then we can check out our filter data to the state of California. It's not too interesting, it's just the state of California. And then our intersected data to show our fires actually in California. So in our last step here, I'm gonna actually intersect both of these data sets. And in the last step, I want to actually send this by email. And we'll go ahead and connect that. As I mentioned earlier, GeoParquet, you can actually export this to GeoParquet and pull this in if you want to schedule that workflow and send that data out, or in CSV or in JSON. So I'm ready to send this analysis. I'm going to send this to Javier and go ahead and hit run. So we'll rerun our steps. It's going to perform the intersection with our buffer data as well as our, our fires in California to see who is nearby a fire. Once that runs and goes green all the way down, great. So we'll check it out, and if we did everything right, we should have an email right here. Great. So you can take a look at this. You can see we have 6 customers that are within 5 kilometers of a fire today. Grab my CSV data, open that up. Here's a list of our customers that are near a fire, and we can take some action on that data step from there.
Wow, thank you, Matt. I think like everything. This is, I think to me, this is a very, very exciting announcement, because it really, if you see, the ease of doing an analysis like this. I'm going to show you, we compare it. One of the things that we mentioned is everything that you've seen gets compiled on the UI, gets compiled into a SQL that then is run into a data warehouse, right? And if you look at it, this is a comparison of, this is the same SQL I did myself manually to do the same analysis versus the analysis that Matt just did. So it's not only easier, it's also the productivity in that sense is much, much different, right? I think this will be a very big through towards the expansion of usage of spatial SQL. Now, of course, maybe I'm a very, very big geek on spatial SQL, but the fact that you can do with importing data from a URL, a save file, directly from the data warehouse in SQL. We're geocoding data, we are doing the analysis, but then we're sending by email, and Matt didn't show it, but I can schedule that thing. I'm going to actually show you, because I think that is mind-blowing too. And if you go to, in the demo, you saw it here, I can go and click schedule. And the analysis that Matt did, now I can say execute it every night. Every night we'll go, get the data, do the analysis, and if there's any new match, you will get an email. So you see, how it's, for me, this is mind-blowing. And again, it gets compiled, it's executed by the data warehouse. I think it's pretty amazing. That's one thing. But not only, it is amazing from the way that you use it as a user, from a kind of a perspective of an organization, running workflows on cloud native, like we are showing, has some very big advantages, as a business. First of all, it's all serverless. You don't have to worry about maintaining any clusters of servers to run them. It's also, they run elastically. So you're only going to be paying for the computing that you are using at the time. You don't need to keep the servers running to be able to do that at 3 a.m. It's very cost effective because of the cost of storage separation, and it's integrated in the cloud. I mean, like, I could be, like putting, this workflow as part of my BI tool. I can chain it with any of the other tools that we're talking. It's all SQL at the end of the day, right? So to me, those are like very, very powerful reasons of why we think, a lot of these workflows are going to move to this cloud-native infrastructure. Now, today we are actually launching this in beta, and we're doing it in partnership with BigQuery, which has been the data warehouse that we've been using for quite some time from the beginning. It has some very, very strong geospatial support. But our goal is to enable it in all the data warehouses that CARTO works. But for that, and to talk around our partnership with Google on this, I'd like to welcome Chad Jennings, who is the Senior Product Manager and Lead Geospatial Analytics Lead for Google. So, Chad, thank you.
Thank you. Thank you very much, Javi. Gotcha. Apparently, I need to be more careful with which pictures I put up on Twitter. So I'm very excited to be here. Javi and I did this presentation a couple of years ago, maybe the last time we were in person. Yep. And this conference is very special because the types of work that we all do as geospatial analytics professionals is very special. So I'm delighted to be here. I'm delighted by the announcements that we're making, that Javi is just making, because if you're democratizing, oh, that's not my slide. There we go. If you're democratizing access to analytics and access to capabilities like that, you enable a lot more people to do a lot of awesome work. Being the guy from Google, though, I wanted to talk a little bit about the infrastructure that Workflows is currently based on. And so I wanted to talk a little bit about how Google is positioning, like, not just geospatial analytics, but a suite of products to support geospatial analytics on Google Cloud. And so we've based this on 4 pillars of technology. All of these pillars have been launched and are generally available. They're all very mature and differentiated products in their own right. And we've designed this offering to go along with the data types and the capabilities that you all need to do workflows. So BigQuery, excellent for vector data. Earth Engine is a serverless processing platform specializing in raster data. The Vertex AI platform is where you can do a lot of, the notebook experience lives there, ML ops, and then, of course, the Google Maps platform APIs for visualizations and for developing applications. And so, my point in bringing this up here is not to provide an advertisement for Google, but rather to let you all see how I and how the other product leaders at Google are thinking about supporting geospatial analytics, not just with BigQuery, but with an entire suite of products that goes all the way across the portfolio.
Great. I think, Chad, this is really, I think, this diagram represents a lot the vision that we have as a data cloud, right? As kind of like building the blocks that can enable a next generation type of connected spatial analytics, that is always fresh, always real time, and that is accessible to everybody. So I think this is super exciting. Now, Chad, the other thing I wanted to ask you about, CARTO and Google have recently signed a partnership around sustainability. And I know that, you and I share a lot the passion towards, things like climate change and, sustainability overall. And we've seen recently, with the hurricane in Florida, the effects, the multiplying effects of climate change can produce in this natural phenomenon, right? And in a way, the importance of information systems towards, mitigation, in a way, the impacts of them. And we did, this project with Hawaii together that I think it's actually very interesting on that. So I don't know if you want to talk a little bit about it.
Yeah, I'd be delighted. I've got a couple things to say about this topic. I'll start with product specific. One of them, the solution that CARTO generated for the state of Hawaii is about measuring and telling which highways in Hawaii are going to be the most susceptible to sea level rise or to erosion, and to places where the state has to tell people not to build or which roads need to be reinforced. So it's dealing with the impacts of climate change on infrastructure. So just as humans on the planet, that type of question is going to get more and more common and more persistent and more dramatic. And so like by equipping all of us with the tools we need to solve like this problem, or for example, like this could be, instead of infrastructure, it'd be climate effects on agriculture, or climate effects on any number of other industries. And so I think this is this is an example of a bellwether that's going to take over much of our lives, as geospatial analytics is really going to lead the intersection between like doing good hard work in analytics and also solving really important human problems.
Thank you. This is great.
Thank you, Thank you very much.
Yeah, so this is great. So I'm just going to kind of wrap it up. I think I started, talking about these three things, right? And like what is, in a way, I mean, like to put it in this framework of like, like where is the spatial analysis done? If you're like thinking about it, I think the Geo Data Cloud or the Data Cloud is right now the most exciting place to be doing a spatial analysis. How you are doing a spatial analysis, and there's many things about, but like spatial indexes is definitely something that you want to consider when you're modeling your data. And finally, by whom? I mean, certainly I hope that, with what we're doing and as a community all together, more and more people will join us and everybody can get to use these amazing capabilities. So that's it. Thank you very much, everybody. I hope you guys have a great conference. I'm definitely looking forward to meet you all in the coffee breaks and around. And yeah, talk to you all soon. Thank you.